Okay, all right, here we go. So I understand you guys had a significant number of questions on this assignment. That's fine. What's that? Should we just start diving in right at the beginning?
Just
Give her a go. Okay, I have this strong sense of confidence in your abilities that if I go through a couple of them, you'll be like, oh, okay, now I get it. So let's just go ahead and do that. Okay, so in the very first one, you are given a couple of triangles. And it's important, a ticky-tack important thing to understand that for all of this to work, what has to be true in the first place about these two triangles? They have to be similar, yes. This doesn't work with just any two random shapes. They have to be shapes that are similar to each other. Similar, but luckily they tell us that they are. Okay? And so when you look at this side length right here and this side length right here, how do they compare? This one's doubled or that one's half. Okay, let's go with half. So if the sides are 1/2 of each other, the whole idea of what we were trying to get to yesterday is what's true about the area. Right, it's this square. Okay, because area is measured in square units, if you know the ratio of the sides to find the ratio of the areas, you square that. 1 squared is 1, 2 squared is 4. So like somebody said, depending on which way you want to look at it, either this triangle has an area that's 4 times that one, or you could think that this triangle, which is smaller, has an area that is 1/4 of that one. Does that make sense? Okay, so now we just have to use the other piece of information that they gave us, which is that this triangle right here has an area of 72 square centimeters. Okay, so you could do it the non-thinking way, which would be to set up a proportion 1/4, because we figured out that was the proportion of the areas, equals x over 72. Or you could just say, well, since this is 1/4 of that, I'm just going to take that answer and divide it by 4. And either way you slice it, you get, bless you, that the area of the gesundheit, the area of the one that you're looking for is 18 square centimeters. Okay? So take the ratio of the sides, square it, and that gives you the ratio of the areas. Okay? Now, number 2 asks you to go backwards, and we did not specifically talk about this yesterday. I had hopes that maybe you would be able to figure this out a little bit on your own, and maybe some of you did, and if you did, that's good. But this time they're going to start out by giving us the ratio of the areas, and they're going to ask us to figure out some information about the sides. So since we're going backwards, what do we have to do? Right, since we're going backwards, instead of taking the ratio and squaring it, we're going to take that ratio and take the square root, okay? So this one right here is angle. And this has a side of 24, and then this one is rect. Get it? Rectangle, get it?
Yes.
Good. Okay, so since they gave us the ratio of the areas this time, like Anthony said, to figure out the ratio of the sides, we have to go backwards, so we have to square root. So what's the square root of 9? 3. And what's the square root of 16? Okay, so that means the ratio of the sides of the two rectangles is 3 to 4. So now if I want to figure out this missing side right there, I'm going to set this equal to another fraction. Does the x go on the top or does the x go on the bottom? How do you know? Because it's what? Because it's smaller. Yeah. Okay. The 9 is smaller than the 16, and this rectangle is smaller than this rectangle. So the way we have this set up is we've decided to put the smaller numbers on top and the bigger numbers on the bottom. Okay? And now you cross multiply and divide, and coincidentally, what do you find out?
18.
That also equals 18. So the answer to the first two columns is both the same. Okay? All right, so now we're good to go, right?
Can we do like the word
Yeah. You want me to just skip to the word columns?
No.
Do you want me to do number 3?
Yeah.
Keep going here. Okay, so now we're working with trapezoids. And nothing about this changes just because the shapes are different. Once again, they're giving us the ratio of the areas. So if you want to figure out the ratio of the sides, what do you have to do? Square root both of those numbers. Did I write that wrong? Yeah. Supposed to be 25. Okay, so what's the square root of 16? 4, and the square root of 25 is 5. Okay, so the ratio of the areas is 16 to 25. The ratio of the sides is 4 to 5. And so we're going to use that to figure out what these missing pieces are. So let me draw this little trapezoid there. And then they're trying to freak you out by making this one go sideways. Ooh, so confusing. Like that. Okay? So this is trapezoid trap. And this is trapezoid load. Okay, so now we know the ratio of the sides, so we can use that to set up a couple of proportions to solve for A and B. So somebody give me a proportion I can use to solve for either one of those variables.
4 over 5
Okay, you know you're going to start with 4 over 5.
equals A over 4.
Okay, but
4 over A.
right, because we're going small number on top, big number on the bottom, so that means we need to go small shape on the top, so 4 over big number on the bottom, which is A. So obviously if 4 over 5 equals 4 over A has to be 5. 4 over 5 equals 4 over 5, so that was easy. Okay, what is the proportion that I can set up to solve for B?
Equals 8 over B.
Okay, 4 over 5 equals 8 over B. So what does B come out to be? 10. Okay, we getting it at all?
Kinda.
Kind of a little bit?
A
Little bit?
Let's do the wood problems now.
Okay, so yeah, let's let you guys, if you need a little more time, you can do that. I guess there's only one more picture one left, but that's the same way. So hopefully you can now do number 4 on your own. What's the answer to number 5? 1 over 49. Good, because it says the ratio of the lengths of the corresponding diagonals is 1 over 7. So to get the ratio of the areas, what do you have to do? Yeah, square it. 1 squared is 1, 7 squared is 49, so you're good to go right there. Okay? All right, so let's get into everybody's favorite word problems. What's the, I don't remember what are we doing now? Which one? 6, okay. Okay, well 6 actually turns out to be pretty straightforward like number 5. It says the ratio of the areas of two similar trapezoids is 1 to 9. What's the ratio of the sides? What do I do with those numbers? What? 1 to 3. Good, you're getting it. So I just take the square root of both of those numbers, and that will be the ratio of the sides. Okay? Okay, what else? Number 7, same deal. It says the ratio of the lengths is m over n. So what's the ratio of the areas? M squared over n squared. Okay, if they give you the ratio of the sides and you need the ratio of the areas, you just square the numbers no matter what they are. If they're numbers or variables or whatever, just square them. All right? Okay, where did we go from there?
8.
We did 8?
Yeah, we did 1 through 10. And
Okay.
14 to 2.
All right, let's take a look at 8 then. All right, number 8 says Annie works in a magazine's advertising department. a client has requested that his 5 by 12 centimeter ad be enlarged. So this person has an advertisement that's 5 by 12 centimeters, okay? And the person says, double the length and double the width and then send me the bill. So if we double the length and double the width, how big will our new advertisement be? 10 centimeters by 24 centimeters. Okay, now the original ad was going to cost the guy 1,500 clams.
3,000.
So the question is, now see, you fell for it.
Okay.
You fell for it. Okay, yeah. Jonathan said 3,000 because he's thinking this side right here is twice that, right? And this one's twice that, so it's going to be twice as much. But my question to you is, as we worked through yesterday, if I had drawn this correctly to scale, how many of these rectangles would fit inside this rectangle? 4 of them, because I would be able to fit 1, 2 this way, and I would be able to fit 1, 2 that way, so I'd get a total of 4 of those original rectangles. Okay? So if the original thing cost 1,500, how much is the new one going to cost? 6,000, yes, not twice as much, 4 times as much. Okay? So we can make some money off of you, Jonathan. Because you'd say, yeah, that's fine, double it, that's good, and then we charge you 4 times as much. You're like, what? No, too bad, we did it. You go. Okay? All right, number 9, solve a problem posed at the beginning of the lesson. An artist uses 200 tiles to create a design that covers a rectangle with dimensions 2 by 3. Jonathan is going to get this now. So we, once again, are dealing with a rectangle. This time it is a 2-foot rectangle by a 3-foot rectangle, and it is going to take 200 tiles to cover that. Okay? He will cover a wall with dimensions 10 feet by 15 feet using the same size tiles. So the entire wall is going to be 10 feet by 15 feet. How many tiles will he need? Okay, so the first thing you do is you look at that and you say, what is the ratio between the sides of this rectangle and this rectangle? Okay, yeah, 5. Okay, this one is 5 times bigger. It's a ratio of 5 to 1. So what will the ratio of the areas be? 25 to 1. Good, you have to square both of those, so the areas will be in a ratio of 25 to 1. So the correct answer is not 1,000 tiles. You do not say, well, they're 5 times as big, so you're going to need 5 times as many tiles. The sides are 5 times as big, so the areas are 25 times as big. So you will need 25 times as many tiles, which is 5,000. You had that time, right, John? You were down with that. What? Oh, I thought you were going to ask me a question. Number 10. Okay, number 10. Assume that a small boy is similar in shape to his father. If his father is 3 times as tall as his son, what is the ratio of the surface area of the father's skin to that of his son? So he's 3 times as tall. Why would you need to know that? I know it is kind of creepy, in case you're like a psycho killer or something. I don't know. Yeah, that's kind of weird. You need to know because you're buying face paint for a Halloween costume. That's why. And you're really, really low budget, so you need to just spend exactly the right amount. Okay? That's why. All right, so if he's 3 times as tall, how much bigger will his surface, keyword area, be? 9 times as big, because 3 squared equals 9 times the surface area. Okay? Okay, and then the rest were review problems? Still couldn't do them? No? Can't do 14. Just can't do it. Tried and tried and tried. Can't do it. Okay, 14, this is definitely one of those tricky ones. How many triangles do I have on the board? 3. Okay, so the key is to be able to see these triangles. What? Oh, thank you. And this is the right triangle also? Okay, I think we're going to have to use that. Yeah, the trick is to be able to see these triangles as the 3 separate triangles that they are. Okay? Now, since the little triangle, the smallest triangle in the upper left, is a right triangle, what missing side can you tell me right off the bat? 4, yes. This side right here is going to be 4 because this is a 3, 4, 5 Pythagorean triple. Okay? So that helps us right there. So now what? Now you're stuck? Well, what else is something that you know since we have 3 right triangles? We used this squared plus this squared equals this squared. What else do we know? We use the same idea. Yes, Hannah?
Wait, they're similar, so the 3 go to the bottom.
Do we know they're similar?
No.
No, it doesn't say that they're similar, so we don't know that they're similar. Dang it. Otherwise, yes, we could have done that. And they might be similar. But how would we know that they are? Maybe they are. Are they similar? What's one of the ways we have to prove that 2 triangles is similar? Are similar. 2 triangles is similar. 2 triangles are similar. What's that? What's the easiest one? The very first one we did? Angle, angle, right? Okay, so let's take a look at this triangle right here. And this triangle right here. Do those have 2 angles the same?
Yeah.
Yes, which ones?
That one and that one.
That one and that one, yeah, good. This one up here is the same angle in both triangles, right? And then they each have a right angle. So are they similar?
Yep.
Yes, okay, so Hannah just forgot to mention that part. They are similar, we know by angle, angle. Okay, and you can do the same thing with this one right here and the whole big thing, right? Because they also both have a right angle and they share this angle right there. So those 2 are similar by angle, angle. So what I'm going to do is I'm going to redraw them to maybe make this a little bit easier for us to visualize. So we have a little triangle, a medium triangle, and a big triangle. It sounds like a bad fairy tale to me. Okay, so what is this side of the small triangle? 4. What is this side of the small triangle? 3. And this side is 5. So those are the 3 sides that we know, so that's going to help us. Now let's focus on this medium-sized triangle. Let's do the easy one first. Bless you. Which one of these 3 sides is the hypotenuse? Y, because it's across from the right angle. So this one is Y. Okay, what's the short leg? 4. And the long leg is X. Okay, good. And then for the whole big triangle, this is a little bit trickier. What is the hypotenuse?
3x.
Good, 3 plus X. What is the short leg? And the long leg is Y. Okay, so now, Hannah, you want to set us up with some proportions that we can use to solve?
Okay, 4,
3, so you're talking about this 3 right here? Okay, so she's going to go 3 over 4. So she's comparing the short legs of the 2 smaller triangles, and that will equal what? 4 over X. Okay? You guys see how she did that? Short leg of the small triangle, goes with the short leg of the medium triangle. The long leg of the small triangle also goes with the long leg of the medium triangle. So if you cross multiply and divide those, you get x equals 5 1/3, or 5.3 repeating, right? Okay? Okay, so now we can use a similar proportion to figure out what y is, and it turns out we don't need that guy at all. What proportion can I use to figure out y? What? 3/4 again, so short leg over short leg equals 5/y. Okay, so cross multiply, you get 20, and then divide by 3, and you get 6 2/3. Okay? So that's what we got going right there. All right, maybe one more. 15. I don't want to do the rest.
Let's do some review.
I don't want to do 15 either. Let's, why don't you just do your own homework? Let's,
We're not all math business.
oh, sure you are. Let's do 20 and 21, just to review a little bit with our area formulas, and then we'll call it good. Okay, 20 says find the area of a regular decagon with an apothem about 5.7 and a perimeter of 37. You what? Yeah, and I don't expect you to remember the formulas, and that's why I always encourage you to write them down. Okay. All right. What's the formula? Anybody remember it or have it written? Good. 1/2 the apothem times the perimeter. So this is actually, nice job, actually a pretty simple problem to give you all the information that you need. Okay? So you're going to go 1/2 times 5.7 and then times 37. And if you multiply those together correctly, you should get about 105.5 square centimeters. Okay? So that one's relatively easy. It's good for you guys to brush up on those formulas, apparently. Okay, and then the last one, this one's going to take a little bit more work. It says find the area of a triangle whose sides measure 13, 13, and 10. This is 21. All right, here's the problem with this one. Let me draw that in a different way. What kind of triangle is it? It's an isosceles. Is it a right triangle?
Yep.
How do you know? Yeah, you don't know. Okay, so we can't assume that it's a right triangle, so I'm going to draw just a regular old, no, well, okay, not to scale. These are supposed to be shorter than the other one, but this is 13, 13, and 10, okay? So I need to find, yeah, I know. Well, this 10 is longer than the 13.
It's okay.
It's okay. Yeah, we'll work through it. It's okay. Thank you, Jonathan, for your support. Okay. What two things do you need to know about a triangle to find its area? Its base and its height. Do we know the base?
Yeah.
Yes, the base is 10, right? We don't know the height, but we can find it. Okay. Because I just made a right triangle and so good, I can use the Pythagorean Theorem. What's this over here going to be? 5, because it's half of the base since it's isosceles. Some of you might know this Pythagorean triple right off the top of your head. Nice. 5, 12, 13 is another one. Okay. If you don't know that Pythagorean triple, then you can just go 5 squared plus 8 squared equals 13 squared. Or 25 plus 8 squared equals 169. Subtract 25 from both sides and then take the square root. And you get what Dakota told us from the very beginning. 5, 12, 13 is one of the common Pythagorean triples, okay? So the base is 10 and the height is 12. So how do I find the area? 5 times 12, right? Half the base times the height, or 5 times 12, which is 60 watts? Square centimeters. Square feet? No. Sorry, I thought it was centimeters. Okay? Okay, so what I need you to do then is, I know there are a couple that we didn't get to, but that's okay, you'll live. Pass those forward, and then since you guys had so many questions on this, I'm going to give you a review worksheet today to get a little bit more practice.
Yeah,
on
I need
this.
the bathroom.
Yeah.
The bedroom.